This conference will now be recorded.
So, so far we discussed about what is containerization, right? So we discussed about Docker. In Docker, we have a lot of concepts like image, container, volumes, networks, compose, and swarm, right? So, so this swarm, Docker swarm, is basically a container orchestration software. So container orchestration software, basically Docker swarm. It's embedded as part of Docker itself. It's embedded as part of Docker itself, but it is not having much features. It is not having lot of features whatever we are going to have in the Kubernetes. So Kubernetes is again container orchestration platform. It's widely used. It's a widely used container orchestration software. Most popular container orchestration software in the market is Kubernetes. So Kubernetes. We will try to understand what is Kubernetes, Kubernetes architecture, and how to deploy the applications in a Kubernetes. And we will try to set up the cluster, Kubernetes cluster, and we will explore. Okay. So we will try to see what is Kubernetes and how it works. Okay. So what is Kubernetes? As I told already, Kubernetes is an orchestration engine, container orchestration engine, and it's open source platform. It's open source platform for managing the containerized applications. It's an orchestration software for managing the containerized application. Responsibilities of any responsibilities of Kubernetes. What do we do in Kubernetes? What is the responsibilities of Kubernetes? Container deployment. We can deploy the containers. We can scale and descale of the containers and container load balancing. So it's an orchestration software, right? So the responsibilities of Kubernetes is like we will deploy the containers and we can scale and descale the containers. As we already discussed, Kubernetes is not a replacement for Docker. As we already discussed, Kubernetes is not a replacement for Docker. But can we consider as a replacement of Docker Swarm? Can we consider Kubernetes as an alternative or replacement of Docker Swarm? Yes. So Kubernetes manages containers. Kubernetes manages containers, container softwares, containers. Docker Swarm supports only Docker containers. Docker Swarm supports only Docker containers. What do I mean? Docker Swarm manages only Docker containers. It can orchestrate only Docker software, Docker containers. But when it comes to Kubernetes, Kubernetes can manage like other containerization softwares also. Initially, we discussed containerization. What are the containerization softwares? Is the Docker is the only containerization software? Is Docker is the only containerization software? No. So what else, if you remember? Container D, and next we have some Rocket, RKT, right? So there are other containerization softwares. Docker Swarm manages only Docker containers. But when it comes to Kubernetes, Kubernetes can orchestrate Docker containers, containerization runtime. That containerization runtime can be Docker in Kubernetes, or it can be containerd, or it can be Rocket, whatever it is. Kubernetes supports other containerization runtimes. It can manage other containerization softwares, not only Docker. Kubernetes is not a replacement for Docker, as we discussed, but it can be considered as replacement for Docker Swarm. Kubernetes is complex. It is significantly more complex than Docker Swarm. It is little, it has lot of concepts. It is more complex than Docker Swarm. It requires more work to deploy. Okay. But Kubernetes cluster will be very strong. You will be having a lot of features in the Kubernetes. So who is the vendor who implemented Kubernetes? Right? What is the history of Kubernetes? So who implemented initially? Kubernetes was developed initially by Google. So Kubernetes born in Google, initially developed by Google. Kubernetes is written in Go or Go language. Kubernetes is developed. There is a language called Go, Golang. So Kubernetes is implemented initially by Google, written in a Go or Go language. Later, they have donated to CNCF. There is one organization called Cloud Native Computing Foundation. Kubernetes has developed by Google, but later they have donated to CNCF. Now, who is owning and who is managing Kubernetes? Now, who is owning, who is managing Kubernetes? CNCF, Cloud Native Foundation, Cloud Native Computing Foundation. Initially developed by Google. You take any Google applications like Gmail, YouTube, right? Google Maps, or you take any application, they are running as a containers. They have implemented those applications as a microservices. Those applications are running as a containers, and they are using Kubernetes as a platform, container orchestration platform, to manage their workloads. So Kubernetes was initially released to market. Kubernetes version 1.0 was released to the market on July 21, 2015. So initial first version of Kubernetes is available for developers or DevOps guys in the market from 2015, which means from how long Kubernetes is in the market, right? Approximately for now, it's approximately 6 years for now, right? So Kubernetes is very hot in the market. Kubernetes is very demanding tool nowadays. Like, you take any project, most of the projects, 95% of the projects, irrespective on which programmatic language they are developing, whether they are developing on Java, whether they are developing on Node.js, AngularJS, or they are developing on Python, irrespective of any programmatic language they are developing, they are trying to build and deploy those applications as a containers. And those containers, to manage those containers, most of the people are using which container orchestration software? That is Kubernetes. Okay. So the first version was released to market on 2015. So current stable release is version 1.2.1. I think now it is 1.2.2. When I documented, it is 1.2.1. I think it should be now 1. When I documented, it was 1.2.1. I think now also it's same. Okay. Kubernetes releases. Yeah. So the latest release is this one again, 1.2.1.3. 1.2 right? When I documented, it was 21.0. Now it is 1.21.3. So which means how many versions has been released from the beginning of the Kubernetes so far? Only one. This is 1.0. Now 1.21, right? So more than 20 releases has been happened in the Kubernetes. They are keep on adding the features. They are keep on fixing the issues, and they are keep on adding the new features in the software, Kubernetes software. So now, what are the advantages of Kubernetes? Like as any other container orchestration software, what are the advantages, right? Advantages of Kubernetes. Automated scheduling. What is meaning of automated scheduling? Right? Again, it's a cluster, Kubernetes cluster. You will have a group of servers. You will have a masters. You will have a workers in the cluster. So we will have an automated scheduling. What does it mean? Right? Kubernetes will have a scheduler which will schedule and create a containers on the nodes. When I want to deploy any application in the Kubernetes cluster, there will be a scheduler, there will be a job, there will be some code, right, which will create a containers on the cluster nodes based on the requirements of the resource requirements. In the same way, the Docker Swarm master will create a schedule the containers, right? Similarly, Kubernetes also will have some code which will schedule the containers on the cluster. Right? And the self-healing capabilities. Here we can see master server. Yes, if it is a self-managed Kubernetes cluster, you have an access to master machine, right? In the same way, Docker Swarm also, we have a master machine, right? We can see master. Similarly, in Kubernetes also, if it is a self-managed Kubernetes cluster, we have a master, we can access master. So we'll understand what is self-managed Kubernetes cluster, what is managed Kubernetes cluster. We'll slowly understand. So Kubernetes having a self-healing capabilities. What is the meaning of self-healing? Kubernetes will replace or reschedule containers when a container goes down or when a node also goes down. Suppose I deployed a container in the Kubernetes cluster. If container goes down, will I get another container again? Yes, self-healing. And also if one of the server goes down in the cluster, what will happen to the containers which are running in that node? What will happen to the containers which are running into that node? The server is down, your containers will down. But what Kubernetes does? It will reschedule those containers to the another node. It will reschedule the containers to the other node, whatever node is available in the cluster. Now we can perform rollouts and rollbacks, right? Kubernetes roll out our changes to the application or its configuration, right? So if there is any change in our application, what is the process, guys? When it comes to containers, the developer modified the code. What is the process to deploy that latest code when we are using containers? What do we do? What is the process if there is a change in the code? Developer will commit the code. Next, what do we do? It will pull the code, pull the latest code, build application image, then that image will be pushed to the registry, then deploy that image, deploy that image, deploy the image in the sense create a container, right? So when it comes to Kubernetes, we are not going to directly create a containers. We are going to create a pods. We will discuss what is pod later. Now this is the process. Whenever there is a change, we can roll out our change. We can deploy our latest code in a Kubernetes cluster. And also, if the latest code, latest image is not working, whatever code you have rolled out, the latest code, the latest image, the latest container is not working as expected, then what can we do? We can roll back. We can roll back to the previous state, previous version of the image. So we can roll out and roll back the applications in a Kubernetes cluster. Okay. If something goes wrong with your latest image, latest code, you can roll back to the previous image, previous version of your application. And also here, scaling and load balancing. So Kubernetes can scale up and scale down the containers. I mean to say, if there is a lot of load, you can increase the number of replicas, you can decrease the number of replicas, you can scale up, scale down. And also, if I have a more replicas, right, will it have an inbuilt load balancing feature? Suppose for one application, for one image, I have more than one container, like I have 3 replicas, 4 replicas, right? There will be a load balancing in future, load balancing feature. So scaling, we can scale up, scale down. We can scale up, scale down the application. I mean to say the containers. So when it comes to scaling, forget about containers or servers. How many types of scaling we have? In AWS also we discussed. In AWS also I have explained. I'm not sure whether you forgot or not. How many types of scaling we have when it comes to scaling? Hari Krishna is saying replica and global. Is replica and global is a scaling types or it's a service types in a Docker Swarm? Hari Krishna, understand the question. I am not asking how many types of services we have in the Docker Swarm. Now I am asking scaling. There are 2 types of scalings. In AWS, when I was explaining auto scaling, I have explained this one. How many types of scalings are there? There are 2 types of scaling. One is vertical, another one is horizontal. Another one is horizontal. So when it comes to the servers, in AWS also we have auto scaling concept. What type of auto scaling AWS supports when it comes to the infrastructure servers? We have done the scaling, auto scaling, if you remember. What type of scaling it does? In AWS, we have auto scaling concept. When we discussed about auto scaling in AWS, right? What type of scaling it does? Whenever there is a lot of load on your servers in AWS scaling is different, container scaling is different. Don't get confused with server scaling and container scaling. Using Docker and Kubernetes, what we are able to scale? Docker Swarm and Kubernetes. Using Docker Swarm or using Kubernetes, what we are trying to scale? Can I scale the servers? No. What we are scaling? Only containers. Within the given servers, we can scale the containers. In the Docker Swarm, I executed Docker scale, right? Container, I want to scale up and scale down. So what type of scaling it has done when I executed Docker scale command? Horizontal scaling, right? So when it comes to servers or containers, there are two types of scaling, guys, which we already discussed, but let me quickly explain. So now let's take a server scenario. Let's take a server. I have one server. So this server capacity is, let's consider, I have taken 2-core CPU and 4 GB RAM. Let's consider. When it comes to server scaling, right? Let's assume I have deployed one application here. I have deployed one application here. Whenever there is a lot of load on this application, what will happen first? Forget about container or server. Whenever there is a lot of load on this server, what will happen? Will the CPU utilization, memory utilization will go up? Will the performance will be impacted if there is a lot of CPU utilization, lot of memory utilization? Now, what is the solution? If it is running out of memory, if your process is running out of memory, so this server has only 4 GB. If this application is running out of memory, if any process running out of memory, what will happen? The process will crash, right? Your application will crash. Your application will crash. Your process will crash. So will you be able to access your application if it is crashed? No. Whenever it is running out of CPU, what will happen? If it is running out of CPU, what will happen? If process is running out of CPU, performance very slow. Your application becomes very slow or it will hang. Guys, if you observe your laptop only, if you keep opening multiple applications in your laptop, you opened lot of applications, you are browsing, and also you are you are opening some development softwares. If you keep installing, if you are keep using lot of applications in your server, your laptop, will it perform well or it will become very slow? System will slow down. If it is If it is running out of CPU, it will slow down. Your application performance also will be very slow. In that case, what needs to be done, guys? There is a lot of load on my application. What we need to do? We need to scale. We need to scale the application or scale that server. How many types of scalings are there? As I told, vertical and horizontal. We already discussed this one, but again I am trying to repeat. Try to follow. Vertical and horizontal. So in case of vertical, what we do? Same replica, only same instance or only one replica, we will increase the capacity. In vertical, we will scale the capacity. We will scale the capacity. So if I increase this capacity from, I will increase this capacity vertical. Same instance, I am vertically scaling. I am making the capacity, I am making this server bigger. Now instead of 4 GB, if I have 8 GB, will I have some, will it improve the performance? And again, will it able to sustain the load? Vertically. Instead of vertical scaling, I can also perform different type of scaling. What is that? Instead of vertical scaling, I can perform one more type of scaling. What is that? Horizontal. What do we do in the horizontal? Duplicating or duplicating the same instance, right? So instead of increasing the capacity of this server, I will bring up one more server where the application will be deployed. I'll bring up one more server. And in front of this, there will be a load balancer, guys. In front of this, there will be a load balancer. So will it distribute the load? Now there is a lot of load. I have two servers. It will distribute the load. And again, even though after having two replicas, if I still have a load, I can scale again, horizontal scaling. Now instead of two servers, I have a three servers. Instead of two servers, I have a three servers now. So will it able to sustain the load now? I am horizontally scaling. Horizontal scaling. Replicas, I am increasing the replicas. This is horizontal. In the vertical is you are just increasing the capacity. You are increasing the capacity of you are increasing your resources. That is horizontal. Sorry, that is vertical. You are duplicating the replica. That is horizontal. This is horizontal scaling. So which one is? And again, does AWS support vertical scaling, guys? Vertical auto scaling. AWS supports vertical scaling. AWS supports vertical scaling, but will it support auto scaling? Vertical auto scaling? No, only horizontal. Vertical you can do manually, right? If you are running out of resources, can you change the instance type in AWS? You might have done also, right? You might have created t2.micro server to install SonarQube or Nexus. If it is not working as expected, you might have increased the, you might have changed. That is vertical. But does that vertical needs a downtime? You need to stop the server to change the capacity, right? But when it comes to auto scaling in AWS, what type of scaling it supports? It's horizontal. Do we need a downtime in horizontal in AWS? No. Right? Similarly, I have a servers. Now let's come to the container scaling using Docker, Swarm, or Kubernetes. So I have a Docker servers. I have a Docker servers. Now, with the help of master, I will create a container. With the help of master, I'll create a container. So as we discussed initially, can I set the limits for the containers also? Even though my server has this much capacity, even though my servers has this much capacity, right? Can I set the limits for my container? As we discussed earlier, like my container can take only 1 core CPU or 1 GB RAM. One GB RAM, right? Now I just created one replica. If there is a lot of load on this application, that container, will it able to sustain? I just created one replica. Will it able to sustain that much load? If there is a lot of load, just one replica is sufficient? No. It is not able to support if there is a lot of load. Lot of people are accessing this application. Definitely what will happen? My process is running inside the container. For that process, I allocated this much capacity. Will it able to sustain if there is a lot of load? Obviously, what will happen? When there is a lot of load, your CPU utilization, memory utilization goes up. In that case, will your the process, the container will crash if it is running out of memory? Will the container process will crash if it is running out of memory? Yes. No, it will crash. If I don't set the limit, it can utilize based on the resources available. But do you run only one container, one application in the servers, or you have a multiple containers? You have a multiple containers, right? So if I don't set the limit, in the real time, it is recommended to set the limits. In real time, it is recommended to set the limits. Why? If I don't set the limit, there is really a bad code. I have written a lot of bad code. Developer has written very bad code. It is taking more CPU and more memory. If I don't set the limits, will it impact other containers? If this guy is taking more CPU, right? In real time, it is recommended to set the limits. Okay? So in real time, we are going to set the limits, guys. When it comes to the Kubernetes or Docker Swarm, when you are deploying, you will set the limits. Now, if there is a lot of load on this application, now what needs to be done? This container, what we do? What we do? We can scale. We can scale. We can increase the number of replicas. Instead of one replica, I can scale to two replicas. So what type of scaling is this? Instead of one replica, I will have a two replicas. I'm scaling. What type of scaling is this? Horizontal scaling. Horizontal scaling. I can manually scale. In Docker Swarm, how did we scale our containers? What command we used in the Docker Swarm? We manually scaled. What command we used? Yesterday only we discussed, right? Do you guys forget? Do we have any scale up command? What command we used? Docker service scale. Docker service scale. The service name equals to how many you want. When I want to scale, manual scaling. So it will scale. When it comes to Kubernetes, We can do the manual scaling. But Kubernetes also supports auto scaling of pods. Pods are nothing but containers. We will discuss in a while. We can scale our pods, our containers automatically. Whenever there is a load, right, it can increase the number of pods, I mean to say containers, and it will decrease the pods automatically, auto scaling. And again, it supports horizontal scaling of pods. What is meaning of horizontal scaling? We are replicating the pod. Instead of one pod, we will be having a 2 pods in the cluster, horizontal. And also, what is vertical scaling? Right? Kubernetes supports vertical scaling of your pods. In case of vertical, we are just changing the limits. We are increasing the limits. Only one pod, we are making this pod more bigger by changing the limits. Right? It can do something like this. Only one pod, much bigger. But which one is recommended out of these two scalings? Whether you take a server or whether you take a container, which one is recommended and which scaling is widely used? Horizontal scaling. So I can scale the containers using Docker and Docker Swarm. Yes, Kubernetes supports vertical scaling of what? What are we scaling in Kubernetes? Are we scaling the servers? Are we scaling the pods? That is more important. Pods, the application, right? It supports vertical scaling also. But no one will use vertical scaling. Everyone will go with horizontal. Why people are not preferring using vertical? Because you have one process only, just one process. You have just one process. Even though you have enough CPU and memory, but there is some other issue with your process. There is some other issue with your process that is not working as expected. Since you have only one process, one replica, even though you have enough CPU and memory, if this process is having an issue, will your application will work as expected? Even though you have enough CPU and memory? No, right? So that's why people will go with horizontal scaling. Guys, again, we are scaling in Docker and Kubernetes our containers. Will it scale your servers? Suppose now I am scaling my pods. Will it scale my servers? Will it change the underlying server capacities? Again, if my cluster itself doesn't have enough CPU, enough memory, even though I'm trying to scale my containers, will it work? Will your containers will be scheduled if you don't have enough CPU and memory in the cluster? No. Provided you have enough CPU and memory in the cluster, enough nodes in the cluster, enough CPU and memory in the cluster, we can scale our containers, right? Horizontally or vertically. Now hope everyone is clear what is container scaling and what is server scaling. And again, horizontal and vertical. And again, if I scale my containers, there will be a load balancing, embedded load balancing in Kubernetes also. So if I have a multiple replicas, if the request goes to the cluster, for that application, if I have a multiple containers in the cluster, there will be a load balancing available embedded. It will distribute the traffic to those containers, right? This is horizontal scaling and load balancing feature embedded in the Kubernetes. We can do the auto scaling of containers, auto scaling of pods in a Kubernetes. But in Docker Swarm, do we have a feature to auto scale the containers? No. Now, Again, service discovery and Kubernetes, load balancing. Service discovery. With Kubernetes, you no need to worry about networking and communication. With Kubernetes, you no need to worry about networking and communication. Kubernetes will automatically assign one IP address to the containers. IP address to the containers, your pods. And there will be a DNS name for the set of containers. Suppose for one application, you have a lot of containers, there will be a DNS name set for those containers. So that can load balance traffic inside the cluster. So I can use the way you have a service name in Docker Swarm, right? If I use that service name, can I use that service name for a communication within the cluster? Suppose one application in the cluster want to access other application in the cluster. Can I use that service name so that it will resolve to IP and it will forward the traffic to those containers, right? Similarly, we have a service discovery and load balancing in the Kubernetes also. You no need to worry about networking and communication because you have a lot of servers in the cluster. You don't know in which server it is deployed. You no need to depend on server IP or you no need to depend on pod IP in the Kubernetes. You can use name, service name. It will resolve to the IP and it will do the load balancing internally if you have a multiple containers. And also storage orchestration. What is the meaning of storage orchestration? With Kubernetes again, what we are trying to manage, guys? With Kubernetes again, what we are trying to manage? Containers. So any data written in the container, will it exist if it is deleted and recreated? No. Any data you write to the container, right? Will it exist if we delete the container and recreate the container? No, right? So we need to mount using values. We need to mount using values. So with Kubernetes also, in Kubernetes also, you can mount the storage of your choice with container. You can mount the storage of your choice. You can go for a local storage. What is the meaning of local storage? The local file system, the server, wherever your pod is running, the host file system, right? Or you can choose the external file systems, external storages like GCP storage, AWS storage, or NFS storage, right? Based on your infrastructure. Now, most importantly, we need to understand the architecture, Kubernetes architecture. It's very, very important in the interview perspective also, and also in the working. Once you get into projects, you should have an understanding about how Kubernetes work. So Kubernetes architecture is very, very important. In the interviews, sometimes they may ask a lot of questions, 10 to 15 minutes. They may ask questions on the architecture, Kubernetes architecture. Kubernetes implements a cluster computing. As I told again, Kubernetes is nothing but a cluster. Cluster is nothing but what? Cluster is nothing but a group of servers works together. Group of machines works together. So Kubernetes cluster, right? Again, in the Kubernetes cluster, you will have a masters, you will have a workers. In the Kubernetes cluster, again, you will have a master, you will have a workers, right? So let me show in the pictorial diagram. Now I have a machines, right? I have some machines, servers. So this is my operating system. I have some operating system. In master, you will have some components. In the worker machine, you will have some components in the Kubernetes cluster. Now, before going that, Banu is asking, sir, I have a 2-core and 4 GB RAM, but my application need 3-core. In that case, will you be able to deploy, guys, that application? What Teja is saying, sir, my server capacity itself 2-core and 4 GB RAM. My server capacity itself this much, but my application need 3-core. In that case, can you deploy that application in this cluster? If your server capacity itself is this much, will it able to schedule that container? I mean to say that application in the cluster, because you don't have any node with that much capacity. You don't have any node with that much capacity. In that case, will your master machine will be able to schedule the container, that application? Because you are saying I need three core processor. Kubernetes has a scheduler. Kubernetes provides scheduler to launch the container on cluster nodes based on the requirements, resource requirements, based on their resource requirements and other constraints. Now your resource requirement is 3 GB, but I don't have, 3-core processor. I don't have any server with 3-core. In that case, will it able to deploy? Does your application will be scheduled? Your container will be scheduled? No, right? Because your server itself, your cluster itself, your server itself has, don't have that much capacity. If you have a this much server, you have a server with more capacity, then it can schedule. Guys, can I increase, decrease? Does Kubernetes increase your server's capacity? Does your Kubernetes increases your server's capacity? Is your Kubernetes is going to manage your servers, or Kubernetes is going to manage the containers in that servers? That is very, very important. You should understand the difference. Kubernetes is just a container orchestration software. Kubernetes can just manage the containers. It will not manage the servers. But if I am using a cloud related cloud infrastructure, if I am using AWS or if I am using Azure, right? Can I use cloud services like cloud concepts to manage my servers? So that is different. Don't get confused with containers and servers. To manage the containers, we have a Docker Swarm and Kubernetes. Sir, in that case, if you want to manage the servers, you need to use basically cloud related services. Okay, sir, how can we know our application requirement, right? You will not directly go and deploy in the production first, right? You will deploy in the lower environments. If you are already in IT, you might have heard about different types of testing: functional testing, performance testing, or we call it as a load test or stress test. Stress testing. Have you heard about these terminologies? Performance testing or load testing or stress testing, right? So what do we do? What a testing team will do? There will be a separate team, normal functional testing team. There will be a separate team. Performance testing, there will be a separate team. What they do first, right? In the lower environments, before it goes to production, they will perform all these kinds of testing. What is the objective of performance testing, right? So I have deployed the application. I have deployed the application, right? And there will be a NFR, not only requirements, there will be NFRs. What is NFR? What is the full form of NFR? Non-functional requirements. Non-functional requirements. So there will be a non-functional requirements, right? What is the non-functional requirements? They will define SLAs, service level agreements. SLA, service level agreements, right? My application should be responding within a second. When I click on my application, I should, I should get a response within a second, right? Or per minute, my application may get 1 lakh hits, 1 lakh requests, 1 lakh requests per minute, right? So it should be able to suffice all these non-functional requirements, right? When people are accessing my application, it should not take more time, because let's take Flipkart is one application. You are one of the end user. When I click on this flipkart.com, if it takes more than 1 minute, will you be happy as an end user? If it is taking more time, as an end user, will you be happy with Flipkart? Are you going to prefer Flipkart if it is going to take more time? No. So there will be SLAs defined, non-functional requirements from the client. I should get a response very quickly. And also, if this is deployed in a single instance, single replica, if there is a lot of people are accessing Flipkart, do you get a faster response, quicker delivery? No. And again, there will be one more thing, request, right? Suppose I deployed in 2-3 replicas, but 1 lakh people are accessing per minute. 1 lakh customers are accessing Flipkart application per minute. Will it able to sustain that much load if I'm deploying in very less resources, less replicas? Again, no. So the non-functional requirements, right? The performance team, the performance testing team, what they do, right? They will using some softwares, we have a lot of softwares like JMeter, Load Runner, right? There are some softwares. Using these softwares, they will simulate the load in the lower environment. They will simulate the load in the lower environments. In the lower environments like UAT or QA. If let's assume I deployed like 4 replicas of that service, 4 replicas of that service I deployed in lower environment. If the load testing is happening, if there is any failures in the load testing, suppose your application is not responding quickly or your applications are getting crashed when they are performing a load testing. So what does it mean? If the load testing is failed, what does it mean? In that case, do I need to consider having more replicas, or also do I need to consider either increasing the capacity of the servers, or do I need to consider increasing the more replicas? So based on the performance testing, based on the load testing and all, right? Based on all these testings, you can decide how many replicas you need and what is the capacity. The application team initially they will give, you may need 1 core processor, 2 GB RAM for this replica, but based on the load testing, you will keep modifying. So you will get a final number after doing all these kind of a testing, guys. Hope you are clear. So now let's continue our topic. Okay, the Kubernetes architecture. When it comes to Kubernetes architecture, what are the components we have? Yeah, initially developer, guys, you take any software when you are trying to deploy, you are trying to run Nexus, you are trying to run Jenkins. Does that software has a minimum requirements documented? In my container, I want to run Java or jar file or Tomcat. Does they have a minimum requirements? Right, like how much CPU you need, how much memory you need, right? So based on that, you will define. Based on that, you will define. That is minimum, but whenever there is a load, it should have some additional CPU, additional memory. So that you will have some more CPU, some more resources. Not only just minimum, you can also set maximum. Minimum this much is required, maximum it can go up to some extent. Now, in the Kubernetes architecture, right, we have a masters and we have a worker nodes, master node and worker node. If you see, Kubernetes is going to manage what? As I told again last time, Kubernetes is going to manage what? Containers, right? So in each and every server, master and worker, what software is required? What software is required? We should have a, it is going to manage what? OS will be there. OS will be there. I am talking about software. What software is required in each and every server? In each and every server, I should have a container runtime. Container runtime. What is the meaning of container runtime? Container runtime software. That container runtime software can be what? That can be Docker or that can be containerd or Rocket. As I told, Kubernetes supports all these containerization runtimes, all these container runtimes, right? As of now, which is widely used containerization software? As of now, as of today, which is widely used containerization software? Docker. As of now, this is widely used containerization software, right? So Kubernetes supports only Docker as a containerization runtime? No. Kubernetes supports other containerization runtimes. Guys, if you are if you are following technical blocks or technical items, right? Kubernetes announced that Docker will be deprecated. If you are following technical blocks or technical things, Kubernetes announced that Docker will be deprecated in future Kubernetes versions. After version 1.22. What does it mean? Kubernetes announced that Docker will be deprecated in future Kubernetes versions. What does it mean? In future Kubernetes versions, does Kubernetes supports Docker in future Kubernetes versions? No, it is not going to support Docker in the future versions. So what does it mean? Can I have a Docker as a containerization runtime? So Kubernetes, instead of Docker containerization runtime, we can have a containerd runtime. Containerd runtime. But can I use same Docker images to deploy even though I have a containerd? Can I use all the Docker concept, like can I use Docker file to build the images? Can I use, whatever images I have built using Docker, will I able to run in the Kubernetes if they are using containerd? Yes, you can still use Docker images. You can still use Docker images, even though you are having a containerd as a runtime. Guys, all these are standards. They will develop softwares. They will develop softwares using some standards, right? They'll develop all these softwares using standards. So all the containerizations follow the same standards, right? All the containerization softwares follows the same standards. So if I am developing, like, if you are aware about interface and implementation, right? What is interface? Interface are nothing but kind of a standard in when it comes to programmatic way, standards, or we call it as a specifications. So for that interface, right, can we do the implementation? Anyone from development background, they can understand this one, right? Interface is nothing but a standard or specification, and there will be implementation, right? Similarly, containerization is one standard. Containerization is one standard, one concept. They have some specifications. Everyone has to follow those standards, those specifications. Now, can I call Docker as an implementation of that standard? Containerd is an implementation of containerization, right? So even though Kubernetes is deprecating Docker, which means there is no impact on your existing Docker images, I can still use those images even though it is using containerd as a runtime. Containerd as a runtime. Okay. So there is no change, right? You can still use Docker to build the images. You still use Docker to maintain your images, Docker registries, right? But only thing, instead of Docker, the Kubernetes may have a containerd. Yes, containerd also open source, free. Why they are deprecating? Why they are deprecating Docker, right? Docker is kind of a overhead in the Kubernetes. Docker is kind of a overhead. It takes more resources when it comes to other containerization softwares, right? So I will share a separate article on this so that you can understand later. I'll share the separate article. So why Docker is being deprecated in the Kubernetes, right? And what is the impact if I am already using Docker in my application, my project? What is the impact we are going to have, right? What does it mean for us, right? I'll share a separate article on that one, right? For now, as I told, Kubernetes supports any container runtime. That can be Docker, or that can be containerd, or that can be other containerization software. So as of now, in each and every server, what we need to have? Container runtime. That container runtime, what we are planning to go now? We are planning to use for now, that container runtime is Docker. Now each and every server should have a container runtime. But when it comes to Docker Swarm, did I install any additional software to set up the cluster except Docker? No. But here, Kubernetes, we have some additional components. Kubernetes, we have some additional components here. If you see in the master machine, what are the components we have in the master machine? What components we should have, or what are the components you have when it comes to Kubernetes? Some additional components. Some additional components you have. You have these components. So this is the architecture of Kubernetes. You have a API server in the master, you have a scheduler in the master, you have a control managers in the master, you have a etcd in the master, right? In the master machine, you have these components. When I set up a Kubernetes cluster, these are the control plane components. The master, we call it this one as a master or Kubernetes control plane. We call it as a master or we call it as a control plane. Kubernetes control plane, right? Master or a control plane, or we call it as a master node also. Master node. This one, these machines we call it as a worker node, or we call it as a slave. In Kubernetes, sometimes if you hear this one minion also nothing but a slave. So in the master machine, you have these components: API server, scheduler, control manager, etcd, right? And here in the worker machine, you have some components. In the worker machine, you have some components. That is kubelet and kubeproxy. Kubelet and kubeproxy. In the worker machine, you have these components. So now, in the interview perspective also, in the understanding of Kubernetes also, this is more important. So now who will manage the cluster? Who will manage the cluster basically? Who will manage the cluster basically here? The master, this control plane. Again, in the control plane, you have some components. You have some components like, what are the master machine components here? In the interview, they'll ask, can you explain Kubernetes architecture? What are the components are there in the master? What are the components are there in the worker? They'll ask. So what are the components in the control plane or master? The important components here: API server, scheduler, control managers, and etcd. What are the components of workers? Kubelet and kubeproxy. So again, they will ask, what is the purpose of API server? What API server does? What is scheduler? What it does? What is control manager? What is etcd? Right? Now, if you see the architecture, I have a API server, scheduler, control manager, and etcd in the master. Now, to deploy or to deploy my application or to remove my application or to update my application in this cluster, whom should we contact? I want to deploy the application in this cluster, or I want to update the application in this cluster. Whom should we contact? Again, master. So how to contact this guy to deploy the application? Again, how can I contact the master? Right? You have a CLI, and you have a GUI. What is the meaning of CLI? What is the full form of CLI? Command line interface. So what is the Kubernetes command line interface? There is a software called kubectl, or we call it as a kubectl or kubectl. So this is a CLI, command line interface. So using this CLI, I can talk to the cluster. I can talk to the cluster to deploy the applications or to remove the applications, right? So what is the meaning of GUI? graphical user interface, application, right? There is a dashboard software. There is a dashboard software, Kubernetes dashboard. Using Kubernetes dashboard, it is like a console, guys. In the AWS, you have a console, right? In the AWS, you have a console, right? Can I create servers? Can I create load balancers using console in AWS? Yes. Similarly, there is a GUI, graphical user interface for Kubernetes. Using that GUI also, I can talk to the cluster and update or delete the application. But we will not use GUI. We will widely use CLI for automation. So Rancher is different. Rancher is basically kind of a software to manage multiple Kubernetes clusters, to create and manage the clusters. Rancher is like another software. Using that, you can manage multiple Kubernetes clusters. You can provision the Kubernetes clusters and you can manage access controls in the cluster. Okay? That is altogether different concept. Okay? Now, I can interact using CLI or I can interact using API. So any command I execute or any request goes, right? Any command I execute, any kubectl command I execute. What is the entry point for this cluster? Like this CLI or this GUI will talk to the which one first? In the control plane, right? There is a concept called API server. API server. What is the meaning of API? What is API? API. API is nothing but application programming interface. So as I already told, Kubernetes is implemented in which programmatic language? Kubernetes is written in which language? Go. Does it mean, do I need to learn Go language? Do I need to write any Go language code to deploy the applications in a Kubernetes cluster? No. So we are using CLI. We are executing a commands in the, using kubectl commands. But in the background, it is going to make a API calls. It is going to make a API calls. You are executing a command, but in the background that is going to make a API call. So any command I execute, the request goes to which one? In the control plane, first API server, right? That API server will process this request. That API server will process those commands. That API server will process the commands. Suppose I want to deploy application. I need to execute a command. So who will process that command in the control plane? In the control plane, API server, right? API server will process the command. Now I want to deploy one pod. What is pod? I will explain later. I want to deploy one pod. I'm going to execute some kubectl commands, something like this. Kubectl run. I want to create a pod using this image. I want to create a pod using this image. So any kubectl command I execute, so who will process this command? Who will process this request? First request goes to API server. That API server will process this command. So what is the entry point for all the administration tasks in the Kubernetes? Any administration task, like you are creating a pod, you are creating a value, or you are updating your application. What is the entry point for all the administration tasks in the Kubernetes cluster? API server. That API server will process the request. This is nothing but a code, some process which will be running. So if the request goes to API server, what API server does first? What API server does, right? Any request, first request is going to something like this, any kubectl command, whether you are creating something, whether you are deleting something, right? The request goes to API server. What that API server does first? Suppose I want to create a pod. What it does? First, it will persist that information in a etcd. It will persist that information in a etcd. That request, that information in etcd. That API server will persist that information in the etcd. Persist, or it is like persist or save, both are same. It is going to save that in the information in a etcd. So then what is etcd? API server is nothing but some process, some application, some code which is going to process all your requests in the control plane, right? And what is etcd? We have a etcd. As I told, API server, Kubernetes API server interacts with API. It is a front end of Kubernetes control plane, communication center for developers and system administrators for other Kubernetes components. So this is the front end for our administration task, API server. You want to do anything in the cluster, the API server will respond, process that task. So similarly, we have a etcd. You have a etcd. So what is etcd? etcd is a data store. etcd is a simple distributed key value data store. It's kind of a database. etcd is a kind of a database. Database for what? Is it a database for our applications, or is it a database for Kubernetes cluster? etcd is a data store, database, kind of database. Kubernetes will use etcd as a database to store the cluster information. etcd is a key value data store. Kubernetes will use etcd as a database to store the cluster information. What kind of information it will store in the etcd? What kind of information it will store in the etcd? It will store node information, how many nodes is part of this cluster. It will maintain pods information, deployments information, volumes information. etcd is a kind of a data store for a Kubernetes. It's not a database for the actual applications. It's a database of your Kubernetes, where it will maintain how many nodes are part of this cluster, how many pods we have created, all that information in the etcd. Okay. Now we have a scheduler. What that scheduler does? The name itself is saying scheduler. What that scheduler will do? Will it schedule? Is it responsible for scheduling the pods in the cluster? Now I am trying to request this master machine control plane. I want to create a pod. That request will be received by API server, and it will persist that information in etcd. And also we have a one more component called scheduler. What that scheduler does? The scheduler is going to schedule your pods. The scheduler is going to schedule your pods to the nodes, right? The scheduler will watch the pods, and it will assign those pods to the nodes, right? So it will try to schedule the pods. It will try to check is there any pod which is not scheduled as of now. It will try to get the information from etcd. The scheduler will try to get the information from etcd, and it will see, is there any pod which is not scheduled? If scheduler identifies that there are some pods which are not scheduled, not created so far, what this scheduler does? Scheduler will create a pods. Right? Now, the scheduler will schedule the pods. And with whom it will work to schedule the pods? The scheduler will try to schedule the pods. With whom it will work to schedule the pods in the nodes? I have a node here, right? Master machine also a node. Master machine also a node, right? I can create a pods in the master also. So with whom it will work in the worker machine to schedule the pods? If you see in the worker machines, basically in the nodes, not only worker, in the master also you have this component, but which is not important. In the master also you have a kubelet, you have a kube proxy, but it is not much important compared to these components. That's why it is not shown here. In the master also you have a kubelet and kube proxy, not only in the workers. In the master also you have a kubelet and kube proxy, but in an architectural level that is not much important when it comes to master. So this scheduler will schedule the pods. With the help of whom it will decide and it will schedule the pods in the nodes? The scheduler will try to use kubelet process, which is running in the node, kubelet. So kubelet is basically a node agent. So this control plane, this master machine, this control plane will use which component in the node to manage the nodes and pods in those respective nodes? This control plane will use which component in the nodes to manage the node and pods in each and every node? There is a component called kubelet. Kubelet is a primary node agent. We have a kubelet, right? Kubelet is a kubelet, the node components, kubelet. Kubelet is the primary node agent that will be running on each and every node, right? Node agent, the control plane will use this kubelet, right? The control plane, the master will communicate with kubelet to manage that node, right? So the scheduler will talk to the kubelet, then kubelet will talk to the container runtime. To pull the image and to create a containers. Scheduler will talk to the kubelet. Kubelet will talk to the container runtime, whether it can be a Docker or whatever it is. It will pull the image and it will create a container. Okay. So kubelet is a node agent. The control plane, the master will use, or master will communicate with kubelet to manage that node and its pods. And we have a control managers. What this control managers does? The name itself is saying control managers. We have a node controller. We have a replica controller. Something like this. There are a lot of controllers. Replica set controller, deployment controller, something like this. So what this controller does? We have a lot of controllers. Control manager runs in the background, which will perform different tasks in the cluster level. So what these guys do, right? There are a lot of controllers like node controller, replication controller, replica set controller. Lot of controllers are there. So each will perform some activity in the background. The node controller, what is the responsibility of this node controller? Right? Suppose any node goes down in the cluster, some program, someone has to watch whether your nodes are up and running or not. up and running or not, right? Someone has to watch whether the node is healthy or not, right, in the cluster. So you have a control manager. There is a node control manager. What that node controller manager does, it is responsible for noticing and responding when node goes down. Suppose one of the node went down, we have a control managers, some task in the background. So if one of the node goes down, what that node control manager will do, it will take some action, right? It will take some action. What action it will take? If this node goes down, whatever parts running in this node, what it does, it will try to reschedule to other nodes, right? So the control managers will perform some cluster level activities in the background. So we have a replica controller, replication controller, something like this. Suppose one of the pod went down. Since we have a controllers, will it be recreated? The control managers, will it be recreated if pod goes down? If node goes down, will it take some action? Right? Who is responsible for all those things? The control managers. Right? So these are the components of a master: API server, scheduler, control managers, and etcd. What is kubelet? We discussed also kubelet. What is kubelet? Kubelet is a primary node agent software, right? Agent software. The control managers, basically this master machine, the control plane will use that kubelet to manage the nodes and its pods. So yes, we have a different control managers. Like here I have told, right, node controller, replica controller, deployment controller. Replica controller will ensure that whatever number of pods you are expecting, it is up and running all the time. Node controller will responsible when node goes down. Right? Similarly, you have some controllers which we will discuss slowly. Okay. Now kubelet is a agent, node agent. Now what is kube proxy? There is a one more component called kube proxy. What is kube proxy? If you observe, you have a kube proxy. The name itself is saying proxy. It's a network proxy. Network proxy. Right? So we have a kube proxy in each and every node, including master also, guys. In master also, we will have these components, right? Kube proxy. What is responsibility of kube proxy? Kube proxy is abstracting the network rules, right? So Kubernetes enables the Kubernetes service abstraction. This kube proxy enables the Kubernetes service abstraction by maintaining network rules. It will perform the connection forwarding, right? Suppose I have some pod here. If I want to access from outside, right? So there will be a software called kube proxy. So the request goes to kube proxy. That kube proxy is going to perform the connection forwarding. It is going to forward the request to the appropriate pods, right? So it is going to abstract the network rules. Kube proxy is required for accessing our pods within the cluster or from outside the cluster. Within the cluster also, if I want to access one pod from another pod, internally it will managed by kube proxy, right? So we will discuss this. There is a service concept, there is a Kubernetes service concept, right? We will discuss again once we discuss about service, this kube proxy. So these are the components of the Kubernetes cluster. architecture, very, very important. API server, scheduler, control manager, etcd, master components. In the worker components, kubelet and kubeproxy and container runtime. But even though here I have not documented, do we need a container runtime? Also, do we have a kubelet and kubeproxy also in the master? Yes. Okay. So architecture is very, very important. If I want to deploy any application, if I want to perform any task in the Kubernetes cluster, what is required? How can I perform? What is the Kubernetes CLI? Don't get confused between kubectl and kubelet. Don't get confused between kubectl and kubelet. What is kubectl? What is kubectl? It's a CLI, command line interface, to manage the operations in the cluster, command line interface. But what is kubelet? Kubelet is a node agent, primary node agent. So this control plane will talk to that node agent to manage the node and its pods. Okay. Now, when it comes to the setup, when it comes to the Kubernetes setup, there are different ways you can run the Kubernetes. You can set up the Kubernetes. Primarily, there are two types of Kubernetes clusters. Self-managed Kubernetes clusters. Primarily, there are two types of Kubernetes clusters: self-managed Kubernetes clusters and managed Kubernetes clusters. Primarily, there are two types of Kubernetes clusters: self-managed Kubernetes cluster, managed Kubernetes cluster. So, what is self-managed? The name itself is saying self-managed. Self-managed. So, what is self-managed? Right? Self-managed. We need to manage the cluster. We need to manage the cluster. Who is responsible for managing the cluster, setting up the cluster? If server goes down, we need to take care. We need to take care. Self-managed, managed by our own, ourselves. So in case of self-managed Kubernetes cluster, who need to set up all these things? The control plane, the worker components. Who need to install and set up all these softwares? We need to set up all these things. You have a server, you install Docker, you install some Kubernetes softwares, you set up control plane, you add a worker machines to the control plane. We need to manage everything. If any issues in the control plane, suppose your API server is down or scheduler is down or your master machine, complete machine is down, is it going to come up automatically if the master goes down, or do we need to take the responsibility of again fixing the issue? If any failure in the cluster, in the master or worker, if worker goes down, that machine completely goes down, do we get another worker in case of self-managed? No. But if the pod goes down, will it recreate the pods even though it's a self-managed? If the pod goes down, it will recreate the pods, but it will not manage the underlying infrastructure. In case of self-managed, it is not going to manage the underlying infrastructure. Suppose my server itself is down, will I get another server in case of self-managed? No. And also any failure in the control plane, your master itself is down, are you going to get another master automatically in a self-managed? No. So we need to manage everything. You need to set up the softwares, you need to initialize the cluster, you need to join the workers in case of self-managed. So we have some softwares like Minikube, Kubedium, Using these softwares, I can set up the self-managed Kubernetes cluster. Using these softwares, I can set up the self-managed Kubernetes cluster, right? Now, managed Kubernetes cluster. The name itself is saying managed Kubernetes cluster. Platforms as a service. Platform as a service, right? In AWS, you have one service called EKS. In AWS, we have one service called EKS. What is the meaning of EKS? Elastic Kubernetes Service. In AWS Cloud. If I am using AWS Cloud, there is a service called EKS. What is that EKS? Elastic Kubernetes Service, managed Kubernetes service. So in that case, who will manage my Kubernetes cluster? Who is responsible for managing my Kubernetes cluster? Do I need to set up all this software myself, or Kubernetes will have that Kubernetes will pre-configure the cluster? That AWS will pre-configure the cluster, right? The provider will pre-configure the required softwares and everything will be up and ready. I have a Kubernetes platform. I can, EKS is nothing but a platform as a service, Kubernetes platform as a service, right? EKS is nothing but a platform as a service, Kubernetes platform. So I will get a platform. In this case, what is my responsibility? I will already have a platform. I will just deploy my applications in that platform. Who will take care about high availability? Suppose for some reason your master goes down. Your complete master control plane itself went down. Do I get another control plane, another master automatically if I go for a managed Kubernetes clusters? Or if my worker goes down, my complete worker goes down, worker machine goes down, will I get another worker also automatically? In case of managed Kubernetes clusters, yes. So who is going to take care about that in the background? Is Kubernetes is take care about itself, right? So Kubernetes is managed by the AWS. It's a platform, guys. It's not a software as a service. It's a platform as a service, Kubernetes platform, right? If you remember AWS, EAS, PaaS, SaaS, service models, cloud service models. Cloud service models, right? This platform as a service, software as a service, right? If you remember. Now, in case of platform as a service, right? Where is the diagram? So in case of platform as a service, it will provide the platforms to create and deploy the applications. So I'm going to get a Kubernetes platform. I'm just responsible for deploying and managing the applications in that platform, right? So in case of managed Kubernetes cluster, do I need to worry about high availability about the cluster? Who will take care? High availability, fault tolerance in my cluster if my control plane, my master went down or my worker went down. Will I get another machine, another master, another worker? Now, if you see this image, where is that image? If you see this image, that where is that image? Here. When I am going platform as a service, we are just managing application and its data. But who is managing the server, its uptime, runtime, the softwares required, middleware softwares, and everything? The provider. In that case, the hardware and also the runtime middleware like Kubernetes related components and server runtime, everything will be managed by the provider. In that case, if there is any issue in my master machine, the master machine is down or my worker machine is down, in that case, will I get another master, another worker? In case of managed Kubernetes clusters, do I need to set up this myself? Do I need to install Kubernetes softwares or Docker software, or automatically it will be managed by provider? It is automatically taken care by the provider. We are just responsible for deploying the application by talking to that cluster. But when it comes to self-managed, who is responsible for installing the required softwares? Who is responsible for maintaining the cluster if something went wrong in your cluster? We have to take care ourselves, right? So in cloud, we have services like EKS in AWS. In Azure cloud, we have one service. If you are using Azure, there is one service in Azure called AKS. In Azure cloud, if you are using Azure instead of AWS, Azure Kubernetes service. If you are using Google cloud, in Google cloud there is a service called GKE. What is GKE? Google Kubernetes engine. Whether it's a AKS or whether it's a EKS or GKE or self-managed Kubernetes cluster, does Kubernetes concept will change or Kubernetes concept remains same? The Kubernetes concept remains same. There is no change in the concepts of Kubernetes. It remains same. But what is managed, what is self-managed, that you need to understand, right? In case of self-managed, we are responsible for setting up the cluster and managing the cluster. If something went wrong, your master went down, your worker went down, do you get another master, another worker? If it is a self-managed cluster, no. But when I go for a managed Kubernetes cluster, do I need to worry about setting up the cluster and high availability of my cluster, my masters and workers? Do I need to worry? High availability of my control plane, high availability of my workers? No. That will be taken care by the respective provider. So in the interviews, they will ask which one you are using, which Kubernetes version, or what type of Kubernetes you are using, or what Kubernetes flavor you are using, or what type of Kubernetes you are using, they will ask. So what is the meaning of this? What Kubernetes flavor or what type of Kubernetes flavor you are using? That depends on your infrastructure. So provided a chance, you to decide which one you will decide, which one you will prefer. Which one you will prefer? Managed Kubernetes cluster, because I no need to worry about this one. But now let's assume your client, you are working on some client, that banking kind of application, some financial related project. Your client is not at all ready to host, or not at all ready to host their applications in the cloud. They don't want to host their applications in someone else's infrastructure. In that case, if your client is not at all ready to host their applications in the cloud, in that case, can we use this managed clusters for that client? If the client is not at all ready to host the applications, they don't want to host their application in someone else's infrastructure, cloud, in that case, we can't go with this one. In that case, can we set up the Kubernetes clusters? self-managed Kubernetes clusters in their own data center servers. The client has their own data center. They are managing the servers. They are managing the networks on their own data centers. In that case, is it possible to set up the Kubernetes clusters on their own data center servers instead of cloud using these softwares? Self-managed, right? Self-managed. We can set up the clusters in their own on-prem servers. Their on-prem servers, we can set up the Kubernetes using this kind of a software. So that depends on the client infrastructure. If client is okay to have a infrastructure in the cloud, in that case, which one is preferred? Self-managed or managed? Managed, right? So we can set up the clusters with the help of these softwares. Self-managed clusters we can set up using these softwares, right? So Minikube is a single node Kubernetes cluster. Single node Kubernetes cluster. In real time, do we use Minikube? I mean to say single node Kubernetes clusters, only one node that will act as a master and worker. We can deploy the application. Minikube is a single node Kubernetes cluster. Can we use Minikube for production purpose? You are using self-managed. Can we set up the production cluster using Minikube? Do we have a single node Kubernetes cluster in real time? No. It is only for developmental purpose, or in dev purpose or developmental purpose. If I want to practice or if I want to do some kind of a POC on Kubernetes, can I use Minikube for a developmental purpose? That is for developmental purpose only, not for production purpose. But using Kubernetes, we can set up multi-node Kubernetes cluster. So if your client is don't want to use managed Kubernetes cluster, if your client want to use self-managed Kubernetes cluster, they want to set up a Kubernetes on their on-prem servers, can I use Kubernetes for production purpose, like actual purpose, multi-node Kubernetes cluster, right? So these softwares will have pre-configured things using which we can set up the cluster. Using Kubernetes, I can set up a multi-node Kubernetes cluster, right? So first I will explain this self-managed Kubernetes cluster. Later, once we are familiar with all the Kubernetes concepts, we will go with EKS. Again, I am repeating, whether I am using a self-managed Kubernetes cluster, whether I am using a managed Kubernetes cluster, does the concept of Kubernetes will change? No. The concept of Kubernetes remains same. Only who is going to manage the cluster will vary. If I am using Kubernetes self-managed, we are responsible for managing the cluster. But when I am using managed Kubernetes cluster, the cloud, the provider will take care about the setting up the cluster. Okay. So next week, Monday, I'll try to set up the cluster using Kubernetes. Using Kubernetes, we will set up the multi-node Kubernetes cluster on the next session. But meantime, there is already video uploaded. If you have a time, try to go through that video. Kubernetes setup, self-managed Kubernetes setup. There is that. Kubernetes setup in AWS using Kubernetes. So go through this video if you have a time. We will set up the cluster on the Monday session. But before that, I wanted you to complete Jenkins and Docker Swarm integration. Before this one, I wanted you to complete all the Docker concept. So Docker Swarm and Jenkins. I want to build and deploy applications into the Docker Swarm cluster using Jenkins, right? There is a video here, Jenkins and Docker Swarm integration. In this video, I am using Docker Hub as a public repository, and also instead of Docker Hub, you can try with next your own like ECR. You can try with ECR, build and push the images to the ECR instead of Docker Hub, and try to deploy. Or you want to use Docker Hub also, that is fine. You try to do with private registry instead of public registry, right? So that you can understand how it works. Kubernetes also has the service discovery and load balancing, right? That's what I already told. Here, service discovery and load balancing. How to limit container resource, everything we will discuss, guys. This is just a first day of the Kubernetes. This is just first day. We have almost another 15 days to go, 15 to 16 days to go. In Swarm also you can limit, right? In the day one itself, I told when I was discussing about the container, right? You have -c number of CPUs, -m memory, how much memory. You need to use all these options. You can limit in the Docker also. So we'll discuss all these things, how to scale up, scale down the containers. I mean to say pods in the Kubernetes, how to set resource request and limits, right? And how service will work. Kubernetes has a lot of concepts. Kubernetes is having a lot of concept. There is a concept called namespaces, pods, services, deployments, replica set, replication controller. There are a lot of things to be discussed, right? Slowly you will understand all these things, how it works. Replica set, replication controller. You have a lot of things to be discussed. Daemon set, stateful set, PVC. There are a lot of things to be discussed. Okay, slowly you will understand what is service, how it works, what is pod, what is the purpose of pod, what is this, what is this. We will understand slowly. Okay, we have a lot of days to go. Go guys. We have almost next 15 days. We will be discussing. So there is a video how to set up Kubernetes cluster. This video, if you have a time, try to go through this video. Anyhow, I am trying to set up in the next class. Even though there is a video in our YouTube channel, I'll not skip this one in the class. I'll set up the cluster in front of you only. Okay. If required, I'll share these instructions also. If you want to set up before Monday class, I'll share these instructions also, whatever I am using in the video. Thank you guys. We'll try to continue in the next class. Have a great weekend. From Monday, we'll continue on Kubernetes. Vishnu is asking, sir, each environment have a different database configuration, right? Is it anything to do with Kubernetes, right? The database, you run your own database, right? Wherever you want to run. You want to run database as a container, run the database as a container. Or you don't want to run your database as a container, you create a RDS service in the AWS, or you create one virtual machine, you configure your database in that machine. Application database is different. You are managing the application database, right? So how to deploy all those things, right? Applications, how to deploy the applications in the Kubernetes, all those things we will discuss, guys. So this diagram is already part of here, right? Nothing much is there. This is already part of our document. I am going to share this document. Okay. We'll continue on Monday, guys. Okay. Thank you. Have a great weekend. Try to practice whatever you wanted to practice. Right? Once we start from Monday, you should be able to only focus on the Kubernetes. What is the problem here? I am explaining Kubernetes. People are still practicing Jenkins, or people are still focusing on Docker or something else. I see people are still working on SonarQube. Now I am discussing Kubernetes. I see people are still working on SonarQube thing. Right? So try to cover up whenever you have a time so that you will be following the latest class. Okay, guys. Next class is on Monday. Thank you. We'll see you on Monday.